In this presentation, we will study the last two sections of the chapter 4, the system of equation, and we will focus in solve problems we call value problems or mixture problems. In the previous sections, we learned how to solve the system of equation. Means if we had two equations with two variables, then we can solve the system by graphical method, by substitution method, or addition elimination method. But in these two sections, we had word problems, and we had to write the two equations with two variables, if it's needed, the two equations of two variables, in order to solve the problem. In some cases, you need just one equations if you have just one variable to solve the problem. The idea is to use that information to write the equations. In order to write the equations, we will use this table to organize, to write all the information we had in the problem. Once we write all the information, we should be able to write the equation. And in these tables, we will have the item 1, the item 2, item 2. This can be, for example, two different kinds of meal, for example, two different kinds of account. This can be anything is in the problem. Here is the number, or can be also the amount, the value, or can be also the percentage, for example, and here is the total. And here also, in some cases, we need to add the number of the items. Then we can write here also the total amount of the items 1 and 2, if we have. And let's try to apply this. Let's try to use this table, some table like that, to solve the problems and to know how to write the equations we need. Once we had the two equations with two variables, then we can solve by any of the methods we know. Then let's start with the first problem. In this case, there were 41 tickets sold for an event. As we had 41 tickets. Tickets for children cost $1.5 and tickets for adults cost $2. Total receipts for the event was $73.50. And how many of each type of ticket were sold? Then we had two different types of tickets. One is for children, the other is for adults. And this is, in this case, we need to find the number of tickets for children. Then we will write here some word that help us to identify the variable. As we had children, and we had here adults. Then the number of tickets. We don't know how many tickets, because we don't know the number of tickets. We will write variable. This is X, this is Y. Now the value for each ticket. What is the cost for one ticket? In case of the children's, we had 1.5. And in case of the adults, we had $2. Always to get the last equation, the last column, we will multiply the first two. Then to get this column, we will multiply X times 1.5. Is the number of tickets multiplied by the value for one ticket. Then we will calculate, we can find the number, the total cost for the children tickets. Then X times 1.5, always we write first, we write first the we first write the number and then the variable. The same we had to do with the next. For in case of the adults, then we had 2y and 2y. Now remember we need two variables. We had two variables, we need two equations. Then the first equation is, we know if we add the number of tickets for children plus the number of tickets for adults, we will have 41. Then the total will be here 41. And we know if we add the cost of the ticket for the children and the total cost for the ticket for adults, we will have $73.5. Then now we had here the first equation, and we had here the second equation. Then now if we add x plus, let's see if I can, x plus y equals to 41. 1.5x plus 2y equals to 73.5. Now we had the equations we need. Then let's write the equation here. We had x plus y equals to 41 and 1.5x plus 2y equal to 73.5. Then once we have this one, the two equations with two variables, we can solve this system of equation by any method, by addition, elimination, by substitution. By graphical method will be really complicated, and we can solve by addition, elimination, or by substitution. Let's solve this one by addition, elimination first. And in order to solve by addition, elimination, we need to get opposites. And let's multiply the first equation by the -2. In this way, we can eliminate y. And let's multiply the first equation by -2. Means we want, then this equation as this, we multiply by -2 each third of the equation by -2. Then we will have -2x, -2y equals to -82. -2y, -82. And then let's add together this equation, yes, which we multiply by -2 with the second equation, which is 1.5x plus 2y equal to 73.5. And let's add these equations together. Then for x, -2x plus 1.5x will be -0.5x, this cancel out, and if we subtract this one will be -8.5. Now we can solve for x, and we can divide by -0.5 by -0.5 on both sides. This cancel out, x equal to 70. Now, once we know x value, we can get the y value. Just we replace this, we plug x value into any of the equations. The first equation is easier, then let's use the first equation. X is 17, and we had x plus y equals to 41, but x equal to 17. This is 41, and let's 17 plus 1, 17 plus 17 plus y equals 41. If we solve for y, then we subtract 17 on both sides, and we have y equals to 24. And now we can answer how many tickets were sold for children. Was X means 17 tickets. For adults was 24 tickets. And we will say here for children, maybe here we can write children. For children was X means 17 tickets. For adults was Y was 24 tickets. And these are the answer. Yes, this is the answer. And let's try the next problem. We will try to do the same thing. Then in a child's bank are 11 coins that had a value of $1.85. The coins are either quarters or dimes. How many coins each does child have? Then here we have two different kind of coins. Then we will write this is what we want to find, as these are we want variables. Then this is the amount of the quarters, times. Because we don't know how many quarters, how many dimes we had, these are the variables. Then we don't know the number, is X and Y. But what we know is if we add X plus Y, we had 11 coins. There's the total amount. Then we can write here the 11. Now the value. Let's write the value in cents. This is the way it's in your textbook. Then in cents, the quarters, the value will be 25 cents and the dimes will be 10 cents. Always, again, to get the last column, we multiply the first two. Then X times 25 is 25X. This will be 10Y. This will be the total amount the child has in quarters. This is the total amount he has in dimes. And we know if we add these two amounts, the total will be 1.85. But we had to be careful because here we had in cents. Yes, this is 25 cents. This is 10 cents. Then we need to write this value in cents. To do that, just we multiply by 100. Yes, then this is in dollars. Yes, we had 1.85 dollars. And if we want this one in cents, just we multiply by 100. Then 1.85 times 100 cents. Then we had finally 1.85 cents. Then if we add these two values, then this will be 185. Now again, now we had the two equations we need. One is this one. The other one is this one. If we add X plus Y equals to 11, we had 25X plus 10Y equals to 185. And let's write the equations here. Then we had X plus Y equals to 11. 25X plus 10Y equals to 185. And now we can solve this equation for any of the methods. Just to review, let's solve this one for substitution. But you can solve for any of the methods you know. The method is easier for you. Let's solve this one by substitution, just to review this method. And for substitution, we had to get first the long variable equation. Then it will be easier to get the long variable equation using the first one. Then let's solve for y. Yes, in the first equation, then we had x plus y equals to 11. And we had y equals 11 minus x. Now we had the long variable equation. Let's go ahead and substitute into the untouched equation, into the second equation. Then y equals this one. Then we will substitute y by 11 minus x plus 10. Y by y is 11 minus x equals to 185. Now we had, once we substitute, we had just one variable, which is x, and we can solve the equation. Let's distribute first. Then we had 110 minus 10x. Yes, we distribute first. Now we can combine the like terms. 25x minus 10x is 50x. Plus 110 equals to 185. Now we can solve for x. Then we can, let's write the equation here. This is 15x plus 110 equals to 185. And subtract on both sides. 110, we had 15x. 75. Divide by 15, divide by 15. Then we had x equal 5. Now we had the x value. And let's go ahead and solve for y. And y, because we already solved for y, here we had the long variable equation. Let's substitute x into this equation to get y, yes, into the long variable equation. Now y equal 11 minus x, y equal 11 minus 5 by x value, which is 5, then y equal to 6. Then now we can answer the question is how many coins we had, for quarters, how many coins for dimes. Then x is the number of quarters. Then we will say for we had 5 coins. In case of dimes, which is y, we had 6 coins. And if we had this if we add these numbers together, 6 plus 5, we had 11. This is the value we expected. And these are the answers. Yes. In this problem, Jolene invests her savings in 2 bank accounts. One paying 5% and the other paying 11% simple interest per year. And in this case, we had 2 different accounts. Then we will write here, this is the account 1, this will be the account 2. One is paying 5% and the other is paying 11%. Then we had to be careful if we had percentage in the problems. We cannot write 5%. We need to convert this 5% into decimal notation. Then to do that, we divide by 100. And we see 0.05. And 11%, we will do the same thing. We will divide by 100, then we have 0.11. Then in the percentage, we will write 0.05. And here in the account 2, we will write 0.11. And she puts twice as much in the lower yield account because it is less risk. Then this is one of the cases. It's easier if we just use, even if we had two variables, it's easier if we just write the two, if we would write the both accounts instead of the one variable. Then using this information, she put twice smash in the lower yield account. Yes, she put twice in the lower one. That means if she puts X here, X amount, in the first one, in the lower interest, she put it twice, is 2X. Yes, 2X. And now we know to get the interest, yes, this, how much interest she got in each account, we just multiply the amount times 0.05. Then 2x multiplied by 0.05. Let's write here 0.05 times 2x. Yes. And the other one will be 0.11 x. And maybe it will be easier if we multiply here 0.05 times 2x is just 0.1x. 0.1x. And we know if we add the interest she got in the first from the first account and the interest she got from the second account, the total amount she will got is $3,738. $3,738. Because we had just one variable, we need just one equation. Then we had the equation just here. Then 0.1x, this is 0.1x plus 0.11x equal to 3,738. Yes, if we add this to quantities. Then now we can solve for x. First we combine the like terms. We had we add this, we had 0.21x equal to 3,000. Now we will solve for x. We divide by 0.21, we divide by 0.21, and x equals to 70,800. Then now we know the x value. Now we can answer the question: how much did she invest in each rate, at each rate, in each account? Then in the account 1, she invests 2 times x, means 2 times x will be 35. Will be $35,600, and this is 2x, means is 2 times right here, 2,000. Means it's 35,600. In the account 2, she invests x, means will be $70,000. These are the answers. These are the how much she invests in each account. Now we will start working with problems, with mixture problems, and let's solve the first problem to understand how we need to complete the table with the information they give when they mix 2 types of substance or 2 types of anything. Yes, they mix 2 things. Then let's start solving this problem. A farmer has 2 types of milk. One that is 20% butter fat, and the other which is 18% butter fat. Then in this case we had 2 different kind of milk, and we can just write milk 1 and milk 2. do we know the amount? Do we know how many gallons we had for each? We don't know. And because we don't know, then we will write X and Y. Then we want to know how much of each, how much milk we need to combine to get 42 gallons of milk, but we want 20% butter fat. Yes, then 42 gallons of 20% butter fat. Then we had X and Y. Then for the milk one, we know the percentage is 24 butter fat. Yes, the percentage of butter fat is 20%. But we know we cannot write this one as percentage. We need to write into the decimal notation. Then 24 divided by 100 will be 0.24. The other one is 80%, 18% butter fat. Then to convert this one into decimal, we divide by 100, then we will have 0.18. Then now, to get the total amount of milk, we need to mix. For milk 1, we need to multiply 0.24 times X. Then 20. Always we multiply these two. Yes, always we multiply these two columns to get the last one. The second one will be 0.10Y. And we know if we add these two amount of milk, 1 and 2, we will get 42 gallons. Here is 42 gallons. Now we know the percentage we want for the mix. Yes, when we mix the both, then it's 20%. Then we will write here is the total milk. When we mix these two, the total amount. Then here we want this in 20% means 0.2. As we divide 20 divided by 100, we will get 0.2. To get the last, we multiply 42 times 0.2 and we will get 8.4. Then to get this one, we will do the same thing. Yes, we multiply 42 times 0.2 to get 8.4. In the same way, we multiply X times 0.24 to get 0.24X. Then we multiply 42 times 0.2 to get 8.4. Now we had the equations we need. We had one equation right here and the other equation right here. Then X plus Y, yes, equals to 42.24X plus 0.18X equal to 8.4. Then let's write the equations. We had X plus Y equals 42. We had 0.24X plus Y equals to 8.4. Now what we had to do is to solve the system of equations. Then again, just for practice, you can solve for the method you want, but let's do this one by elimination to review this method. For elimination, the idea is to get opposites in one of the variables, and when we add the equations together, we can eliminate one of the variables. Then let's multiply the first equation by negative 0.18 to eliminate Y. Then we will multiply the first equation by negative 0.18. Yes. Let's by negative 0.18 by negative 0.18 by negative 0.18. Then we will have negative 0.18x negative 0.18y equals to negative 7.56. If we multiply 42 times negative 0.18, we will get negative 7.56. Now we add this equation with the second one, yes, with this. We add, and we had 0.24x plus 0.18y equals to 8.4. Add the equation together, and then we will get here 0.06x. This cancel out. This is we 1.84. Now we solve for x. 0.06, 0.06, cancel out, x equal to 14. We had the x value. Now we need to find the y value. Then we can plug the x value into the first equation or the second equation. But it's easier in the first equation. Then x plus y equals to 42. Then but x is 14. Is 14 plus y equals to 42. Then let's solve for y. Then this is 1. And this one, y equals to 28. Now we can answer the question is how much he need for the milk 1, how much he need of milk 2. If he combine these two milks, he can get 42 gallons of 20% butter-fat milk. Then for milk 1, yes, for milk, then the answer will be for milk 1, which is 20% butter fat. He needs x. X is 14 gallons. Yes. For the milk 2, which is 80%, he needs 28 gallons. And these are the answers. Yes. And let's now similar problem. This is also mixture problems, and it's similar procedure. Just in this case, we had different things. Yes. Then this is in a candy shop. This chocolate which sell for $4 a pound, and in this case we want to mix the chocolate with the nuts, and then the pound of nuts is sold at $2.5. Then if these two if the chocolate and nut are mixing, then he wants to sell this one at 3.5 pounds. The mix, yes, the mix is 3.5 pounds. Then he wants to know how much chocolate and how much nuts should be used to make 30 pounds of the mixture. If the pound of the mixture is sold at $3.5. And let's try to write here the information we had. Then we know we had the variables we need to find is the amount of chocolate and the amount of nuts. And let's write here nuts. We don't know the amount, then we will write here the variables will be x, y, but we know the value for 1 pound. Yes, for 1 pound of chocolate is $4, and for nuts is 2.5. And we know when we mix the amount of chocolate and the amount of nuts, we will have 30 pounds as the mixture, and we will have 30 pounds. And the price, the value for 1 pound of the mix is of the mixture is 3.5. Yes, this is we know. Now we know how to get the last column. Always to get the total. In case of the chocolate, just we multiply these two values. For x, we write always first the number and then the variable. And here will be 2.5y. And here we need to multiply. 30 multiplied by 3.5 is 105. And to get this one, we multiply 30 times 3.5 equals to 105. Now we have the equations we need. We need two equations to solve the problem, because we have two variables, we need two equations. And here, this one plus this one equals this one. Let's write the equation. X plus y equals 30 for x plus 2.5y equals 105. Again, you can solve this one by any of the methods. Let's solve this one by substitution. By substitution, we need to get the long variable equation. Then we can get the long variable equation if the first one is easier. Yes, there is no coefficient for the variable, it's easier. Let's solve for y in the first equation to get the long variable equation. Then x plus y equals 30. Then subtract x, y equals 30 minus x. This is our long variable equation. Now we will substitute the y value into the second equation. Then we will have here is 4x plus 2.5y, but y is 30 minus x equals to 105. Then now let's distribute here. Then it's 4x plus 2.5 times 30 is 75. 2.5 minus x is minus 2.5x. Now let's combine the like terms, as this is x. Let's combine the like terms. 4x minus 2.5x equals to 1.5x plus 75 equal to 1.5. And now we solve for x. Then 1.5x equals to 30. Divide by 1.5, divide by 1.5. X equals to 20. 20, yes. 20. Now, because we have the long variable equation, yes, it's easier to find y if we just replace, we plug x into the long variable equation. And we had y 30 minus x, y equals to 30 minus 20. 30. Now we can answer the question then, how many pounds we need of chocolate, how many pounds we need of nuts. When this mixes together, we get 30 pounds at this price, yes, at this value. Then we will say, in case of the chocolate, we need 20 pounds, yes. Case of the nuts, 10 pounds. Yes. And if we add 20 plus 10, we will 20 plus 10, we will get 30. And these are the answer. Now these are two additional problems is involve the rate and distance. We already did these problems in the previous chapter, but let's review this again. Then in this case, we had in this case we had Alvin paddled for 2 hours with a 5 kilometers per hour current to reach a campsite. Yes. Then maybe it's good to do some, as we have here. Here is the canoe. Yes. Then this 5 kilometers per hour is the current of the river. As this is 5 per hour is the current of the river. As this is the current. Then he moved from this to this point. Yes, from this to this point, and this to 2 hours. 2 hours. Then he returned against the current, yes, against of 5 kilometers. When he paddled, when he returned, the current was against, yes, and this took 7 hours. And we want to know what is the speed of the canoe without a current. Yes. And we want to know what is the speed of this canoe. Yes. This is, we don't know. Yes. This is the x, the value is the speed of the canoe. And let's try to write this how we can write this information here. Then the first is we can write this one in this direction. He paddled with current. Yes, then we will write here was when we return in this direction was against current. Then we will write here against current. Then here, what was the rate? Because he paddled in this direction with current, then will be x plus the current of the river. Then the total rate, yes, the total rate in this direction was x plus 5. But when he paddled against the current, then the speed of the canoe in this situation will be x minus 5, because he paddled against of the current. This is, we need to subtract the speed of the speed of the current. Now the time when he paddled with current was 2 hours, against was 7 hours. And we know how to get the last column. Yes, just we multiply rate times time. Then it's 2 x plus 5, and here will be 7 x minus 5. Another thing we know, when we move from this point to this point, he paddled that distance, but when he moved from this, then the distance are equal. And we can say is the distance, I will write just with current like that, and the distance he paddled against current are equal. Yes, means this distance and this distance are equal, they are the same. Then let's write this one here, 2x plus 5 equals to 7x minus 5. Now just we need to solve for x, and x will be give the speed of the canoe without current. Yes, just the speed of the canoe. And let's distribute here let's distribute here, and we'll have 2x plus 10 equal to 7x minus 35. Then let's try to get all the variables on one side, and will be 10 5x minus 35. Solve for x, 35, 35. 45 equal 5x divided by 5. Then 9 equal to x. Then now we know x is the speed of the canoe without current. Then the answer is the speed of the canoe without current is 9 and will be kilometers per hour. Yes, this is the answer. And in this particular case, even if we had two different information, we can write both in terms of the one variable. If we can do that, is easier to solve. If we do it that way, it's easier to solve the problem. And let's go with the last problem. And it's similar problem. In this case, we had an airplane that travels 480 miles in 3 hours with the wind. Yes. But in the return trip, the plane travels against the wind, and it took 4 hours. Yes, 4 hours. And we want to know what is the wind speed and the speed of the airplane in still air. And we want to know what is the speed of the airplane without wind. Yes, this is we want to find. And let's write this one. Let's write this one here. What information we know. Then this is when the airplane travels with wind and with against wind. Now we need to write the rate. Then here we need to define x. X will be just the speed of the airplane. Let me write here the speed of the airplane in still air. And y is the speed of the wind. It's the speed of the wind. Then when the airplane travels with the wind, then the total speed of the airplane in that situation will be the speed of the airplane in still air plus the speed of the wind. But if the airplane travel against of the wind, will be x minus y. X minus y. Maybe this is the hard part of the problem, is to know how to write the rate. The other part is easier because the information is there, is in the problem. Then when the airplane travels with wind, the time is 3 hours. Then we write here 3, and against the wind is 4 hours. And we know to get this, just we multiply 3 to get the distance. We multiply 3 times x plus y, and 4 x minus y. Now, because we had two variables, we need two equations in this case. Yes, because we had x and y, we need two equations. But what we know is in each case, the airplane travels 480 miles, as this is the distance, the total distance. Then we can use that information to write both equations. Then in one direction, as in this direction, the airplane, I am not good doing that, but it's travel 480 miles, and it's the same thing. Then we can write this is the distance with wind, which is 3x plus y, and this is distance is 480, and in the other direction is the same distance. Then let's write the other equation will be 4x minus y equals to 480. Then now we had two equations and two different variables. Now we can solve and let's do by elimination. Before to start solving the problem, let's first distribute. Yes, let's distribute this one. Then we will have for the first 3x plus 3y equals to 48. 4x minus 4y equals to 48. Now let's review. Let's solve this one by eliminations to review what happened if we want to solve by elimination, but we had different coefficients, different values along with the variables. Then because this is positive and this is negative, then we can say we want to eliminate y. Yes, we want to eliminate y. But to eliminate y, we need to get the same number here. Yes, we need to get the same number. Then because we had 3 and negative 4, the first thing we need to do is to find the LCD. The LCD is the number we want here to eliminate y. Then the LCD, let me write here, the LCD, then we will solve by elimination, addition elimination. Then to get the opposites y, we need to multiply by the LCD of 3 and 4. And the LCD is 12, yes, it's 12. Then we want to get 12 here and 12 here. Because in this way, when we add the equations together, we can eliminate y. To get 12, we need to multiply by 4. Then, let me see if I can do here something. I don't know. Then, let's do. Then to get to, we need to multiply the first equation by 4. And multiply by 4, multiply by 4, multiply by 4. To get 12, we need to multiply the second equation by 3, by 3, by 3. We don't need to multiply by negative number because we already had opposite signs here. Yes, we already had opposite signs here. And let's go ahead to multiply by 12 each term of the first equation. Then 4 times 3 is 12x plus 12y. 4 times 480 is 1920. Let's do the same thing with the second equation. We have 12x minus 12y equals to 1440. Now we can eliminate y, yes, because it's positive, negative. If we add the equations together, and we will have here 3,360. Solve for x, we divide by 24, divide by 24, and x equals to 140. Now we need to solve for x, and to do that we can just replace the x value into any of the equations. Then we can maybe in the first equation we can do, then just replace x here to get y. Yes, then we had 3x plus 3y equal x, but x is 140. 3y equals, and here we will have 3 times 140 will be 420 plus 3y. Solve for y. Y equals to 60. Divide by 3, divide by 3, y equals to 20. Now we can answer the question. We know the x and the y value. Then what is the speed of the airplane in still air? Then we will say here for the first will be let me write here and this. Let me write here. Still air will be 140 miles per hour, and the speed of the wind will be 20 miles per hour. And here is the answer for both equations, for both variables. Then this is all for this presentation. I hope all of you are well. I hope all of you stay safe. Okay, bye.